Hi, my name is Saanvi Ibrahimpatnam. I'm the project manager, and this is our final project. Our team analyzed the data of current NBA teams to predict the winner when given two teams.
Hi, I'm Lucia Vargas. I'm a statistician, and we used a combination of 2022, 2023 data for STEAM statistics and matchups. These data sets were combined so that we could find our target variable, which was the outcome of each match.
Hi, I'm Hayden, and I'm going to be talking about the teams and total wins bar graph. It's one of the first graph we made. This graph shows total wins per each NBA team. It's organized from most wins to least. Using bar graphs to look at our data helps us determine which statistics are actually relevant for prediction. And so we can make more advanced graphs below. And as you can see, the Denver Nuggets, despite winning this most recent season, they did not have the most wins this season, which means it's not directly correlated. That's just one example of how this graph can be seen as useful.
So this is our heat map. This heat map represents the relationship between visitor and home teams, specifically how any two variables between the home and visitor teams are correlated. This helps us identify what factors contribute to a winning team. For instance, visitor wins and home total losses were correlated with the coefficient of negative 0.12 and positive 0.12 respectively. This means given a matchup of two teams, if one team has more total wins, the other team is less likely to win an individual game. The opposite is also true. However, even these relationships are relatively small. The small relationship between our target variable and features make our classification a little hard to distinguish and give an actual accurate prediction.
Our final graph that we're going to show is our histograms. So basically what the histograms do is they sort teams within wins and losses and then overlap them on top of each other, along with drawing a dashed line to represent the mean for each win and loss. And what this does is it allows us to easily compare teams that win and teams that lose and the difference in certain data points between them. So the overarching theme that we got here was that there's only very minor differences between NBA teams that win more and lose more, which I guess makes sense because all of these teams are in the NBA and all teams have similar levels of skills. And these minor differences can cause an account for winning and losing.
So, hi, my name is Sahistha, and one of the AI models that we used was called KNN, which stands for K nearest neighbors. And pretty much how it works is that there's like a K value that chooses how many points near the data point that we want. For example, if K was 3, it chose the two blue and the red dot that was closest to it. And the score that it gave us is how well our trained data fits our test data, and accuracy is just pretty much how correct we were, which even though the scores were pretty low, it was the most accurate model overall.
Another AI model that we used was random forests, and they worked by using a common algorithm that involves multiple branches and the process of elimination to get its ultimate conclusion. Random forests fit well with our data because of the ability to experiment with our parameters, specifically altering the max depth and n estimators to improve our score and accuracy. While random forest gave a relatively average accuracy in comparison to the other AI models we tested, it did end up producing the highest score.
Okay, so neural networks, they basically work like neurons would in a brain, and each artificial neuron is connected to other neurons around it. Basically, they as the neural network trains, it will adjust the strength of each neuron, and that's I guess how it trains to get a more optimal result. Whenever it gets a more and that's how it gets a more optimal result. Sorry, I'm kind of nervous. Unfortunately for us, despite how good neural networks tend to be for their application, our purpose was not very good for neural networks. It was not a good option for our data, and it's probably just because basketball games tend to be very random, volatile, that sort of thing. So yeah.
So we use confusion matrices, which pretty much just tell you how right or wrong your model was. There are 4 quadrants, which is the true, positive, and negative, and then the false positive and negative. So true positive is when the data is positive and it was correctly predicted true. And then true negative is like the opposite, is when the data was negative and it was like correctly predicted. And false positive is when the data was negative but incorrectly predicted positive. And then false negative is just the opposite, and it's when it was positive but it was predicted negative. So for the K&N matrix, it was more well-rounded overall, predicting both wins and losses, while there was 26 true negatives, 33 true positives, 27 false positives, and 64 false negatives.
The confusion matrix for the random forest model demonstrated a more balanced distribution compared to the other 2 models. This observation prompted us to acknowledge the fact that random forests had significant issues, such as possible random decisions and correlations that the AI model made having no measurable causation. This led to having a result of 72 true negatives, is 51 false positives, 49 false negatives, and 48 true positives. As a result, the overall accuracy of the random forest model accumulated to approximately 55%.
So our final model was our neural network model. And the thing with the neural network model was that it was really, really good at predicting losses. It had 112 true negatives, and it really sucked at predicting wins because it only had 5 true positives. And this was kind of an overarching theme between all of our models, that they were much more likely to predict losses than they were wins. And another downside of our neural network model is that it has like the black box nature of it. So we don't actually understand why the model decides wins and losses. So it makes it hard to interpret why it's deciding so many losses over wins. And our model had a 53% accuracy, which was the lowest out of all the other models.
So this is our trier model component. As you can see here, there's 2 drop downs, one for the home team and one for the visitor team. Here we can match any 2 teams and predict who wins. We can start with looking at the final 2 this season, the Denver Nuggets and Miami Heat. So our model accurately predicted who won, which were the Denver Nuggets, which is really cool and showcasing how influential our model can be.
So results and final conclusion. Overall, our model score and accuracies are lower than desired. This is because the NBA data is always changing. Also, some variables such as net rating are pretty subjective. Other variables such as pace are basically completely uncorrelated with team wins. NBA matchups are often volatile and result in upsets that our data has difficulty predicting. While the overall accuracy could be higher, our accuracy was good given the randomness of NBA games.
In the future, we hope to improve our data by using more team data that is relevant to the issue, or simply further training our model on the statistics and matchups of previous seasons. Additionally, some of our models could be improved through feature engineering. Specifically, K&N works better with fewer, highly correlated features.
Specifically, when we made this website, we did not use any of the bootstrap setups. So we made all of this from scratch using HTML code. So we made a sidebar to navigate things, as well as a light switch, which you can switch from dark mode and light mode.
Yeah, I made the light switch. Yeah.
Sorry for taking your spot, Mark.
It's okay. It's okay.
Do you guys just want to give an overview of yourselves in the About the Team section?
Yeah. So again, I'm Saanvi Ibrahimpatnam. I'm going to be a rising senior. I really got an interest about cybersecurity and AI. Want to take that to the next step in the future. So I thought this was a really cool application.
Hi, I'm Mohammed, and I'm also a rising senior. And I did this camp in order to learn whether or not coding in AI is something that I want to do in the future. And I just want to say this camp was an awesome first experience, and it's definitely pushing me more into the field.
I'm Sahistha, and I'm also an incoming senior, and this camp really exposed me to more coding, and then made me realize how much interest I have in the future.
Hey, I'm Austin. Guess who else is going to be a senior? I did this camp because programming is something I've done for years, and I wanted to try something different. I've never really done anything AI related till now.
Hello, I'm Lucia. I graduated high school about a month ago, and I've learned so much from this experience. I'm truly grateful to have had such an amazing team and incredible support when it came to coding in Python and HTML, and I can't wait to continue coding when I'm an engineer.
I am Hayden. I also just graduated about a month ago. I joined this camp to get more coding experience in order to understand how AI works. I've been interested in art for a long time, so seeing AI threaten that passion of mine drew me in. So now I hope to use what I've learned about AI to make sure that it's used fairly and that regulations can be put in place.